I'm Randy Reed, editor of the EdisonReport, and we're at our 4th annual discussion of lighting topics, which is hosted by the NLB Board of Directors. We're in Washington, D.C. at the IBEW International Office, and we appreciate them allowing us to use their facilities. I'm joined by Kevin Hauser, Mark Lien, and Dr. Mark Ray. The title of this conversation, we're going to discuss the color metrics with TM-30. And Kevin, I'd like to start with you. What's wrong with the old CRI system that I grew up with?
Well, there's primarily two things that TM-30 is trying to address that are limitations of CRI. The first is that CRI was only ever intended to be a measure of fidelity, and there's other aspects of color rendition that are important, and so I believe, and many others do, that it's important to supplement a fidelity index with other measures, for instance, a gamut index and graphics that support saturation and hue shifts. The second part is that the color rendering index is susceptible to numerical problems when the light sources are highly structured, meaning they have peaks and valleys or discontinuities in the spectrum, as would be common with, say, triphosphor-fluorescent lamps and many LED lighting products. So TM-30 is really designed to address those two things, develop a more accurate and mathematically correct measure of fidelity, and provide supplementary information to complement that measure of fidelity.
And
Please.
And there have been other metrics proposed, certainly over 20 recently, that are proposed as replacements for the CRI RA number. They haven't gained the momentum that TM-30 has. But the industry, I believe, is united that we need to come up with a new metric. The question that I think we're going to discuss here is whether this is the right one.
And we have the metric. IES has passed it. TM-30 has been printed,
Yes.
and it is being implemented.
Yeah, but I would like a clarification from Kevin at this point about, it's not an ANSI standard. Is it a standard or a technical memorandum?
Well, it's an Illuminating Engineering Society technical memorandum, so it is a TM document. All documents within the IES library, as I understand them, are considered standards, but to your point, it is not an ANSI standard. Perhaps TM-30 or something like TM-30 will eventually lead to that, but at this point, it's a computational procedure that is voluntary.
So if it went through the process of becoming an ANSI standard, then there would be a vetting process, comments, it would be a public forum, and it might modify TM-30 in some way.
Yes, I think that would be a good idea.
Okay.
Dr. Ray, what's your thought of TM-30?
Well, I think it's a letdown, actually. I think that, to Mark's point, is there's been a lot of discussion, 20-some metrics and so on. So I think there's a broad understanding that color rendering index when you were a boy doesn't necessarily describe the color rendering properties of light sources. And so the idea that at least one more dimension, there could be several more, but at least one more dimension called saturation is better at predicting things like preference. People tend to like more vivid colors, but not too much. It's sort of like the three bears, you know, too hot, too cold, but just right. And that does seem to have cultural differences. Studies we've done in Sweden indicate they like more muted colors, whereas in South Asia, they like more vivid colors. So this saturation is a meaningful metric to people. And I think that has stimulated a lot of development in the lamp manufacturers, and I think we're seeing new products based on those two-dimensional concepts. So I think TM-30 is disappointing because I think I think first of all the so-called fidelity metric doesn't really do much more than color rendering index ever did. Certainly for white light sources. I mean, you can take extreme ones. The variations among that are, there's no empirical data to justify it, to say, well, this one's better than that one. No one's ever done a psychophysical study to say one's better than the other. So it's my father can beat up your father kind of argument right now. But if you got a correlation of 0.98, you kind of doubt that it's much, so it looks like a big deal, but it's not really. The second, the gamut area is a relative metric when in fact gamut area is an absolute metric. So you can have two 100s that are very different in their gamut area, but you would not know that by reading the document. So it's kind of misleading, and I think unnecessary. I think it was framed more of an aesthetic judgment rather than a functional one. There's certainly no data to support TM-30. So I think misleading in terms of being oversold. But you know, in the end, once it's vetted, as Mark says, I mean, we'll probably discover the pros and cons. But I want to say that, you know, I admire Kevin immensely. I mean, he actually got the IES to do something and get a publication out and go through the consensus process. And I consider that an extremely positive step. It's just a letdown for me.
Okay, so perhaps moving in the right direction, though. We've received a few questions, and I want to read this one. There's a direct correlation between the fidelity and saturation numbers. As color saturation is increased, fidelity is decreased. How do we prevent regulations on our industry that require high fidelity, like we've seen with the CRI, the 90 CRI minimums in California and other places?
Yeah, and let me address that with a comparison. Eastman Kodak made a lot of different types of films, and they made consumer films for color preference. If a consumer liked more heavier blue saturation, they had a film called Ektachrome. If they liked more reds, they had Kodachrome. They also made films for color fidelity, ones that would be used for inspection areas, for areas where perhaps globally you had to repeat a color and make it very precise. But it wasn't the high fidelity films that consumers preferred. So when it comes to lighting, we need the ability to manufacture products for consumer preference. That would be the RG portion of TM-30. But that brings down the fidelity metric. So if regulators come in with a high fidelity metric like they did with 90 CRI in California, it will prevent manufacturers from coming up with products that ultimately would have greater consumer preference. There's a trade-off involved. Would you concur?
I agree precisely with what Mark is saying. TM-30 offers metrics, but it doesn't offer criteria for those metrics. And I think that's actually perhaps subtle, but I think it's a very important distinction. The fidelity index RF in the TM-30 method is a very objective way of characterizing fidelity, and the gamut index is a very objective way of characterizing gamut. It's done in a single self-consistent calculational framework, so I think Mark Ray and I perhaps disagree on the value of a relative gamut index versus an absolute gamut index. But in my assessment, because the color temperature is selected as a single criterion within an environment, that it's important to have both the fidelity and gamut index based on a particular adaptation condition and a single correlated color temperature. But coming back to your point, Mark, I think we do need to now go through a process with TM-30 where we begin to develop a consensus for what fidelity RF values are meaningful and what gamut values are meaningful. And so that would go through, in my opinion, that will go through a process of consensus, but also a process that's supported by research. As Mark Ray, you pointed out, there has not been, there's only been a small amount of psychophysical research essentially looking at how light sources are preferred within the space of RF and RG, and more work like that needs to be done so that we can essentially make bracketed recommendations that would be sensible. Fundamentally, I agree with your points. We need to develop the appropriate ranges so that it's not restricting product development.
So in the meantime, how do we phrase this discussion to prevent perhaps the Department of Energy, DLC, CEE, the California Energy Commission, putting a fidelity metric in place?
Sure. So
until we know the answers, until we've done the research.
I'm not on the regulatory side, so I don't think I can answer that directly because I'm not involved in the development of those codes and standards. However, what I think is very important at this point is for people to get familiarity with TM-30, begin to use it, and when I say use it, I mean specifiers requesting TM-30 data from manufacturers, and manufacturers looking at how their sources score in terms of fidelity and gamut indexes and in terms of the color vector and saturation icons, as well as some of the secondary indices that are part of the method. I think it's only through that familiarity that people are going to begin to understand how sources that they're familiar with score on this system. Because the truth is, any sources that we've been using and are familiar with, they're no better or worse than they were yesterday, but they might score a little bit differently on these measures. And so we need to understand how the different scoring might be translated into codes or standards.
So Mark brought up an interesting point. If the alignment between RA and RF is as close as we've heard, and I've heard two arguments on this, then why do we need to come up with RF if we already have CRI? Can we not build on that and add a gamut?
Sure.
index?
Well, let me come back to that correlation, because correlation is not the only way to look at this. CRI RA is particularly problematic when your light sources become what I would call highly structured, which means they have peaks and valleys, they have spikes in them. So if we take, say, a CRI of 80 and look at a basket of light sources that would include LED light sources, linear fluorescent sources, HID sources, we'll see a range in the fidelity index of about 86 to roughly 74 or so. So maybe there is, actually I think it's a little larger than that. So we might see about a 16-point spread in the fidelity index in comparison to the CRI index. And I think that's actually quite substantial. The way that you get a correlation of 0.99 is if you start to include a lot of broadband sources in the mixture in calculating your correlation index. And of course, if you have a broadband light source, like something like a calcium halophosphate fluorescent lamp or daylight or incandescent, then there's going to be very high correlation between the fidelity index and the CRI index. So looking forward, I'm imagining that we will see many more light sources that are highly structured, and LED light source manufacturers, I believe, will be motivated to do that, in part because you can get higher luminous efficiency of radiation and therefore greater source efficacy. And so when we're looking ahead to new light sources, I think it's highly important and very relevant to have a fidelity index that cannot be selectively optimized or gamed around a small number of test color samples.
Please.
Well, I think this is the misleading part. Kevin used the word accuracy, but you, in truth, have no idea what accuracy is. You've never done a test, so a 16-point spread could be negatively correlated or uncorrelated or any number of things. You just don't know. And I think that's the problem. It's being oversold as more accurate because it has 99 chips when there's no proof that that makes any difference at all. Now, it's true that people will game it, but they're only gaming from, say, a CRI of 78 to get to 80, and so they're going to tweak it. But you can't actually see a difference between 78 and 80 anyway. So it's a game that you're playing with regulators. It's not reducing the uncertainty of specifiers on what is a good color rendering lamp. This is all a fiction about accuracy because you have no evidence it's more or less accurate. And a correlation of 0.98 for commercially available light sources is telling me it's not a robust metric. It's because some are going to win, some are going to lose, but in the end, you don't even know if they make any difference at all in terms of people's perception. The point is that you can even see a negative correlation with RF and what people prefer. That's why you need a second metric, which is the saturation metric. And I want to go to Mark Lien's point because in terms of regulations, we seem to jump to the conclusion that we have a metric and needs to be regulated. You know, when you have a restaurant where you have to have certain health requirements, but you don't regulate how much ketchup you can use on your hamburger. And I think saturation is like that. You should be able to provide the people in Sweden with what they want, or an individual, and the people in South Asia. That should never be regulated. You want to make sure there's no impediment to energy efficient lighting technologies. So you can't have monochromatic sources or ones that distort colors and so on. But once you get in the ballpark, let people choose, as they did with the example I thought was excellent that Mark gave about Kodak. Let people choose what they want. Give them a metric that's predictive. And the problem with RG, I don't think it's predictive yet. I'm not saying it's absolutely true because there are no data where you did a head-to-head check on that. But the research that we've done, looking side by side, you're not going to necessarily take a value of RG and be able to reduce your uncertainty to the point where I say, oh, well, I've got a high number, it must be good or bad. You just need more information. So it's problematic in my view, and I think it's definitely being oversold when people use the word accuracy when there is no evidence that it's more accurate or less accurate.
I'd like to find out on the RG aspect how you weigh in on the color vector graphic and the color saturation graphic.
It's very pretty.
Thank you. I think it is too. But I've actually seen a lot of interest amongst colleagues on those two graphics already. I'm not sure how a specifier would use them, but is that something that you think could be?
Well, what happens is everything's
useful?
done to a circle and you see a bulge or a retraction, okay? But as you go to compare it, you don't know what that means absolutely. So if you have a low CCT lamp, for example, you see a bulge that goes out, and say, oh, well, it must enhance my reds. That's not necessarily true, because you could pick a lamp that is white, which is another point we ought to talk about, is what is white, because the reference sources, I'm not buying that, frankly, as reference sources. It's aesthetically pleasing, but I don't think it's functional. But the point is, you can get greater enhancement of a particular hue with one that would be a smaller bulge in that diagram. And so you're going to be misleading people thinking they've done something. And this idea about choosing correlated color temperature, I can show you a CCT at 2700 and you'll swear it's cooler than a 2900 or a 3000 because you're stuck on the black body, which doesn't mean that it's going to look that way. So you're not really choosing CCT, you're choosing tint, which is not correlated with CCT either.
But you say stuck on the black body. We want to be on the black body.
Why?
No?
Tell me why. Tradition.
Tradition.
But that doesn't tell you what's white. And white is an important aspect of choosing an illuminant. People really want to have white light sources. And a 2700 on the black body is a yellow light source. People, not everybody, and it depends on the context and so on, but it goes back to Mark's point, choose what you want. But when you talk to commercial, industrial applications, people don't want yellow light sources, they want white ones.
Right.
And they're not on the black body, except at higher CCTs. So there's a whole bunch of uncertainty, and I think it's distinctly misleading to put TM as progress on our understanding of color rendering.
If it starts the conversation, Mark.
Yes, I think that's great.
Okay.
I absolutely do.
So 5 years.
That's what we're doing now.
Yeah.
5 years from now,
It is.
where will we be? Any idea?
In my dream world,
Yeah. Yeah, let's hear that.
we're absolutely committed to using light sources for a purpose. You want to do brain surgery, you got to select the right light source and so on. I think that the issues that we're involved in are multifaceted. You've got efficacy, you don't want to waste energy, you've got color rendering, which is what we're talking about now, but you have circadian, you've got visual performance, all of those things come together.
Right.
Each of those deserves a metric, if you will, to reduce your uncertainty, but I don't believe they should be regulated. I think these are things that the community needs to communicate. If you do it this way, here's how I can decide whether I'm doing better or worse to meet these design objectives. I don't see any reason why we can't say color rendering per watt if that's my design objective. That's the most efficacious light source. If color rendering is the only thing you care about, you want to light your strawberries and your green peppers and everything else, why is it not the most efficacious light source to deliver the highest color rendering per watt? This lumen per watt thing is a millstone around the industry that
Right.
we just need to cut it loose and begin to think about what we're trying to achieve, and then have the metrics that reduce the uncertainty of the specifiers on how you're going to get there. And I think that's why I'm disappointed in TM-30. I think it adds confusion and it's oversold because it's not really reducing our uncertainty about what constitutes good color rendering.
That brings up a question, and Kevin, this one's going to come to you. I've seen conflicting information, or at least it appears conflicting to me. You're very rational about saying that this is the beginning of the discussion and that there will be some vetting process involved. Mm-hmm. But in a couple of documents that I've read, one that I think is going to be published soon, it says the time is now. I believe I heard that in the second webinar as well. The time is now to embrace TM-30. How do you reconcile that?
Well, I think you're referring to an open letter that's going to appear in Lighting Research and Technology.
Yes.
That's signed by 30, I think there's approximately 30 people now that have signed the letter, that is in support of adopting TM-30. But I should be clear that when it says adopting TM-30, that does not in any way imply or mean that we want it to go into codes. It's just actually calling for use of TM-30. So for manufacturers to begin, again, to supply information and specifiers to begin to request that information. I do think that's an important part of moving the discussion of color rendering forward. I actually, I do believe that the RF method and the RG method, the two indices, are very meaningful numbers, especially when they're used together. They have perhaps less meaning when they're segregated and used apart, but they're intended to be used as a pair. And if they're then complemented with one of the color vector graphics or color distortion graphic, you then can get a very complete understanding of how color rendition might occur under a particular source that's in question.
I believe I've seen where IES has done webinars, it's doing webinars, and maybe DOE as well. How are we going to educate the market on TM-30?
Sure. I think the webinars are a start. They were DOE IES sponsored. There's 2 of them. Those are available on the DOE SSL website, so people can view them if they didn't view them live at the time. Many people that were involved in the development of TM-30 are going to be involved in conference presentations over the next year, and so those will be other opportunities. And I honestly think general use, so purchasing the TM, using the spreadsheet software that's a component of the TM, that will allow a specifier, a designer, a researcher, a manufacturer to begin to understand the system.
Kevin, do you think it's too confusing as it is?
Well, I think that's a good question, right? So when we go from a single index CRI to a more complicated system, there's always that potential to be introducing confusion instead of clarity. The truth is, color rendition is not a simple problem, and you cannot characterize it with one number. So if you try to do it with one number, you're just going to be wrong. You'll be able to characterize perhaps one dimension of color rendition, but not the whole story. And so we did it in a way that TM-30 does it in a way that we believe is as simple as you can do it. Two numbers, a gamut index, which characterizes saturation, a fidelity index, which characterizes similarity to a reference illuminant, and a saturation icon, which gives some information about, as Mark was describing, where you have enhancements in saturation or decreases in saturation.
Mark? Regarding the complexity of it, it's necessary that as our industry progresses, that it evolves and becomes more complex. And what you're proposing, intuitively, it has advantages. As Mark noted, we haven't tested those yet, we haven't done the research, but intuitively it seems to offer advantages, certainly going to the 99 colors. But there are so many people in our industry that have lighting as something peripheral to their regular jobs.
Right.
The energy service companies, for example, the interior designers, an architect, an engineer, maybe lighting is part of what they do, a distributor. I mean, it just goes on and on.
Mm-hmm.
So they're looking for something extremely simple,
Mm-hmm.
and perhaps willing to trade off the simplicity for a level of accuracy.
Mm-hmm.
CRI has been with us for decades,
Mm-hmm.
depending what iteration you're talking about, a long time. And this likely will be, whatever we implement, whether it's TM-30 or whatever we proceed with, whatever variation we proceed with, it's going to be with us for a long time.
Mm-hmm.
So do you think it's premature to have those parts of the industry educated and exposed to TM-30 before it's vetted?
Well, I don't think so. I mean, I think there's already been a fairly significant vetting process. TM-30 went through the entire consensus process, starting with the task force, through the color committee, through the technical review council of the IES, through the board of directors. It also received some external reviews as well. So it's not as though it's a unvetted document.
I apologize.
Yeah.
It's not an unvetted document, and I, having been on the board of the IES, I understand with you.
Yeah.
I understand the nature of getting something through, and Mark alluded to it as well. You've really had a significant accomplishment to get this to the point that it's at, but it hasn't been vetted by the industry yet.
Right. That's correct. Yeah, that's correct. And I think everybody that I know that was a part of the development of TM-30 is very open to commentary, criticism, constructive feedback that will lead to maybe a better version of the system. You know, it wouldn't be called TM-30 anymore, but whatever it might lead to. Nevertheless, I wouldn't call TM-30 a starting point by any measure, because it's built on decades of research that went into the development of TM-30. So, but it is not the final answer either. It's a midpoint.
So should we educate these consumers that have lighting as a part of what they do on something now that the industry will likely weigh in and change before it comes, for example, an ANSI standard, and then we really confuse the issue?
Well, I believe the answer to that is yes. I think we should start using it now.
Packaging?
No, I wouldn't go that far. I wouldn't put it on consumer packaging at this point. No. In fact, I think that's actually another interesting question. The color saturation icon, I mean, certainly that was something we thought about as something that would potentially be useful for consumer packaging, but nevertheless, I think there would need to be market research done on the best way to communicate color quality. And it may be that the color saturation icon is not bad. It may be that the color saturation icon is something that's fairly easily understood by lighting professionals, but not by a general consumer at a grocery store.
Okay. Thanks.
Okay, closing thoughts?
Well, Randy, I'd just like to thank you for organizing this, and NLB and EdisonReport for doing this.
Well, happy to do it, and thank you for your work. Okay, gentlemen?
Thank you, Randy.
Thanks, Randy.